Good evening, everyone. I'm Vicente. I'm a consultant, and first of all, thank you everyone for coming over. It's a cold evening, and I appreciate everyone leaving the comfort of your home. My name is Vicente, and I'm a consultant that help founders building AI workflows and agents that are reliable and easy to evolve. And today, I want to walk you through some tools and systems that I use to build products or better products in a world where everything changes, because probably you guys have realized that every couple of weeks there's a new model, there's a new prompting technique, and we have to rebuild everything from the ground up or not. So before we get started, raise your hand if you've dealt with something like this before. And don't worry, it doesn't fit on the screen, it's a massive prompt. There's 1, 2 people, thank you. Raise your hand again if you had to fix a problem in production, or your PM asked you to add a new feature, or ChatGPT started hallucinating last Tuesday, and you had to get back to this and fix it and just see what the hell was happening here. And I think this is the problem. Prompts are load-bearing infrastructure that we approach as a string concatenation problem. And by the way, this is an actual prompt that I used in one of my projects in production. So I want to introduce you guys to a new way of thinking about prompts. What if there was a better way to model them? And what if they look like functions? Everyone here probably is familiar with what's a function. You use define what goes in, define what goes out. You let the framework or your platform just run with it. And this way you detach yourself from the nuances of dealing with a model, with a large language model, which we know is a little bit of a pain. So this way you can decompose your workflows your prompts into workflows, and you can start modeling and evolving your products using a higher level language or vocabulary. And this is the core idea behind DSPy, the paradigm. DSPy stands for declarative, self-improving Python. I know this is a Ruby meetup, but I reframed it from a Ruby perspective, but I just kept the name. I call it DSPy.rb. And so from now on, instead of prompts, we're gonna start calling them signatures. And so what is a signature? It's basically a contract between you or your app and your LLM. So we lived in a world before where we used to manually write these massive prompts and do the string interpolation and blah, blah, blah. And now we can actually write a contract that governs the relationship between your app and the model. And so you start by describing the goal of your task. We are summarizing an article in here. Then you describe how you're going to provide the necessary information so the model is successful completing it. And the last step is defining how you want to get the results back. And so far, we've been using plain Ruby, a very little amount of natural language. And what happens is that DSPy compiles all this into a prompt underneath and sends it over to your LLM. LLM validates inputs and outputs and just gives you back a really nice object with your summary properly wrapped. So what happens before we get there, and this is what I was referring before, models change, prompting technique changes, everything changes around our apps that usually change at a slower pace. So these contracts anchor your app to the present and give you a roadmap to evolve your app. So what happens if you wanted better summaries? Because this one is just giving us a straight summary, doesn't do much. So what happens if we wanted to get something better? We could change the prompting technique. We could do, imagine that you learned that a chain of thought is a better technique, still simple, that in theory, according to the papers and research, improve the results of what you're asking for the LLM about. And with DSPy, you can actually put them together side by side and compare them. In this example, predict, which is a prompting technique, just goes straight to the answer, while chain of thought adds a reasoning step. And you can access it as a regular Ruby object as well. So with this, okay, we can run things side by side, we can compare which one's better. And the truth is that we really don't know because, well, we can actually read the summary and form an opinion, but we don't know exactly how to make it better. And some other people, or maybe me in a past life, we would test this in production, but we're not gonna do that today. I don't know, and that's where Evals come in. Just gonna take a couple of slides, bear with me. We want to evaluate the quality of our summaries. So we're gonna use DSPy, the same framework, to ask the LLM, hey, is this summary good for this article that I'm trying to, that you just summarized? And this way we can model the prompt and the context using Ruby objects as well. Just like we can model like this is my grounded summary, this is the accuracy or the mindset I want you to apply to the model, to the evaluation, and it can just like give us back this like 5-dimensional model that's called G-eval, which is like a fancy way of saying just like, hey, is this readable? Is this factually correct? And a few more things. So with this, we can start thinking about, okay, I can start modeling or thinking about what is better, what's not. And before we get into more details, let's do a quick polling here. Which from the predict or the chain of thought, who thinks the predict it's better, it's gonna get better results? Okay, we got 2 people, 3, 4, thank you. And chain of thought, who thinks it's a little bit better, it's gonna be better results? It's a little bit more people, 4.5, okay. So how this leads us to how we're gonna measure quality. We understand it as human beings, but how do we measure quality with some accuracy? And we need a metric to score these results. And in defining these metrics is where teams spend most of the time and the effort, because there's no one metric to measure the quality of every single problem. And it really depends on the instance of the problem you're trying to solve. And some examples in here, just like we are using an LLM as a judge to evaluate whether this like free form text is actually good or not. But in other scenarios, LLMs really shine when classifying unstructured data. And in that case, we would need to define other metrics like accuracy or precision or recall. All right, so these evals and metrics guide your team's course of action, informing the next steps in the development process, as we are familiar with. And what I really like is that they introduced planned decision points, which is basically a sequence of low risk and reversible decisions, because that way you can create opportunities to reassess your course of action and whether you need to change it or not, instead of like doing one big monolithic decision, spend 3 months working on a feature and then shipping it to customers and things don't work the way you expect. So Evals in this piece of code, tie everything together, your predictors, your examples, your metrics, so you can run both approaches and compare the numbers. And I think we're gonna look at the numbers because I did run them before. And so I think chain of thought was winning and the getting straight the answer was a little bit behind. Let's see what happens. And chain of thought barely wins by 3%. But the interesting point in here, it's not the numbers or who wins, it's just like what's important for us as a team building AI features. For example, when you look at the data in here, chain of thought is stronger with faithfulness and coherence, not relevance and fluency, cool. But that gives you and your team an option to make trade-offs, like are these dimensions good or not? Or what is what I need to improve that is important to our customers. I haven't mentioned yet, but DSPy.rb, which is this framework that I'm presenting, comes with a few more tools out of the box that I'm gonna show you in a minute, because it's not only just like writing signatures or writing signatures basically, or switching models. We also need observability. We need to know what's going on in production. We don't need like Neo's metrics vision to figure out what's going on in production while our customers are using our products. And with DSPy.rb, all these things that I showed you before are traced via OpenTelemetry, and you can just like dump it into Langfuse and see what's going on. And this is one of the experiments that I've been running lately, which is a chat with ephemeral memory. And you guys are familiar with OpenTelemetry. You can see what's going on, what are the inputs, what are the outputs, what's the cost, the response time, so you can actually see and keep track of what's going on. I've introduced you guys to 2 of the 3 predictors that DSPy, the core predictors that I'm shipping. The third one is basically a tool building agent called as React, and it just like needs to provide it with the tools that it needs to just access the outside world, in this case, the internet. That probably is gonna lead to a different talk. We're not gonna dive deeper in today because it's a lot of work. And finally, last but not least, I told you guys that I said that you would never write a prompt again. You would write Ruby code, but we need a way to actually, how do we improve these prompts? How do we make them more optimal? And we can, building on top of the evals that we saw before, we can let the models optimize our prompts. And once you've defined your metrics in your evals, you can actually steer the model to write a better prompt that is going to give you better results. And this is one of those decision points that I showed you before from a project that I worked before. We did some runs, some tests, I passed in some training data, and we got a little bit better accuracy, a little bit better precision, and recall improved as well. And we did that in iterations, one step at a time. All right. We've seen contracts that survive model changes. We've seen strategies you can swap, like the prompting techniques. We've seen decisions you can measure, all one step at a time. And we've seen a little bit, I teased prompts that can self-improve. 20 years ago, I think everyone remembers this one, the model view controller architecture gave us structure to build web apps and web services and be productive with it. And I think the DSPy paradigm, which it's implemented in many languages, by the way, besides Ruby and Python, give us today the structure to build apps around AI. And with that, comes to an end. Thank you for your time.